December 1941. The United States just entered the war and military planners faced a nightmare that kept them awake at night. Where do you put 3 million soldiers? Not just put them, house them, protect them from weather. Give them somewhere to sleep, eat, plan, and store equipment. And you need to do this on every continent from Iceland to Australia, from the Aleutian Islands to North Africa. The German Wehrmacht had the same problem, and they solved it the way Germans typically solved problems in 1940 with engineering precision, detailed blueprints, and traditional construction methods. Their standard military barracks cost $15,000 per unit. That's roughly $230,000 in today's money. Each one took a specialized construction crew 6 weeks to complete. They were built with timber frames, concrete foundations, proper insulation, pitched roofs, and all the careful craftsmanship you'd expect from German engineering. Then there was the American answer, a curved metal shed that looked like someone cut a giant soup can in half and stuck it on the ground. The Quonset Hut cost $1,000, 15 times cheaper. And here's the part that made logistics officers weep with joy. 6 untrained men could bolt one together in 16 hours, not 6 weeks, one day. That cost difference wasn't just about money. Think about what $15,000 bought you in 1942. That was enough to manufacture 3 Sherman tanks or 5 jeeps or equip 75 infantrymen with complete gear. Every time you chose the German approach to housing, you sacrificed serious firepower. But the real genius wasn't in the price tag. It was in the speed and flexibility. When you can assemble a building in one day instead of 6 weeks, you're not just saving time. You're changing what's possible. You can build a hospital on a Pacific island 3 days after Marines take the beach. You can construct an entire air base in North Africa before the dust settles. You can house 10,000 troops in England in the time it would take to frame one traditional barracks. The Quonset measured 20 ft wide and 48 ft long in its standard configuration, 960 square ft of usable space. The entire structure weighed less than 7,000 lb and shipped in one truck. You could stack them on cargo ships, fly sections in on transport planes, or haul them across deserts on flatbeds. The German barracks required foundation materials, lumber, skilled carpenters, electricians, and weeks of good weather. Miss one supply shipment of nails or timber, and your entire construction timeline collapsed. By 1945, American factories had cranked out 160,000 Quonset Huts. They covered every climate and every purpose: barracks, headquarters, chapels, hospitals, mess halls, repair shops, warehouses, even post offices. From the permafrost of Alaska to the jungle heat of New Guinea, that simple curved design worked everywhere. The Wehrmacht, meanwhile, kept building their engineered barracks the old way. Beautiful structures, really solid, well insulated, exactly what you'd want if you had unlimited time and money and weren't trying to fight a global war on multiple fronts simultaneously. But wars aren't won by the side with the nicest buildings. They're won by the side that can get the most resources to the most places in the shortest time. This is the story of how a prefabricated metal semicircle became one of World War II's secret weapons, not through superior firepower, but through superior logistics. In September 1939, when Germany invaded Poland, the Wehrmacht had around 1.5 million men under arms. By June 1941, when they launched Operation Barbarossa against the Soviet Union, that number had swelled to 3.8 million. The German Army Group Center alone, just one of 3 invasion forces, contained over 1 million soldiers. Every single one needed somewhere to sleep, somewhere to store ammunition, somewhere to repair vehicles, somewhere to treat wounded men. The United States faced an even more explosive expansion. In June 1940, America's standing army numbered 170,000 men, smaller than Portugal's. 18 months later, after Pearl Harbor, the U.S. Army needed to grow to 8 million men. The Navy and Marines added millions more. This wasn't gradual growth. This was an emergency expansion that dwarfed anything in American history. The Civil War mobilization looked tiny by comparison. But the real nightmare wasn't just the numbers. It was the geography. Germany initially fought on its borders, then moved east into Poland and the Soviet Union, south into the Balkans, and west into France and the Low Countries. Challenging, yes, but mostly contiguous landmasses with existing road and rail networks. Their supply lines could stretch from German factories to frontline positions via established infrastructure. America's war existed on a different scale entirely. The distance from San Francisco to Manila, 6,900 man-hours across open ocean. From New York to Casablanca, 3,400 meter. From Seattle to the Aleutian Islands, 2,000 km through some of the worst weather on Earth. American forces needed bases in England, Iceland, Greenland, North Africa, Italy, India, China, Alaska, the Aleutians, Hawaii, dozens of Pacific islands, Australia, and New Guinea. And every single location needed the same infrastructure: housing, hospitals, maintenance facilities, storage depots. Consider what this meant in practical terms. When the 1st Marine Division landed on Guadalcanal in August 1942, they brought tents. Tents in a climate where it rained 200 in per year and equipment rusted overnight. Within weeks, they desperately needed permanent structures for hospitals, ammunition storage, command posts, and repair facilities. Traditional construction impossible. There were no lumber yards on Guadalcanal, no concrete plants, no local contractors. Everything had to come by ship from thousands of miles away. The Germans faced similar challenges in different environments. In North Africa, Rommel's Afrika Korps needed shelter from 130-degree heat. On the Eastern Front, soldiers required protection from 40 below winters. In occupied Norway, troops stationed above the Arctic Circle dealt with darkness and cold that made conventional construction nearly impossible for months at a time. Both militaries scrambled for solutions in 1941 and 42. Both needed to house millions of men in dozens of countries across every climate zone. Earth offers. Both needed structures that could serve as barracks, hospitals, workshops, and warehouses. Both needed buildings that wouldn't collapse in tropical storms or Siberian blizzards. The fundamental equation was identical: massive numbers of troops multiplied by vast geographic distances divided by urgent time constraints. Germany defaulted to what they knew. Traditional construction methods scaled up. They would engineer their way through the problem with characteristic thoroughness and precision. The Americans, arriving late to the war and lacking Germany's construction traditions, had to improvise something entirely different. They needed a solution that could be manufactured in Michigan, shipped to Morocco, and assembled by non-spices in less time than it took to dig proper latrines. They needed something that didn't exist yet. The Wehrmacht standard-type barracks followed principles established by the Prussian military in the 1800s. These weren't temporary shelters. They were permanent installations built to last decades. The typical design featured heavy timber frame construction, concrete slab foundations poured 2 feet deep, double wall construction for insulation, peaked roofs with proper drainage systems, and separate rooms for different functions. Each building measured roughly 30 x 100 ft and could house between 60 and 80 men in proper bunks with storage lockers. Construction began with site preparation and foundation work, which alone consumed 1 to 2 weeks depending on soil conditions. Then came the timber framing. Posts and beams cut to exact specifications, mortised and tenon joints, everything fitted together by experienced carpenters. The Germans used standardized plans, but standardization didn't mean simplicity. Each barracks required approximately 12,000 board feet of lumber, 200 bags of cement, 3 tons of roofing materials, windows with proper frames and glass, doors with hardware, electrical wiring for lights and heating, plumbing for washrooms, and interior finishing work. The construction crew for one barracks numbered between 15 and 20 men: master carpenters, apprentices, concrete workers, roofers, electricians, plumbers. These weren't unskilled laborers. Germany's construction industry relied on the apprenticeship system, men who'd spent years learning their trades. You couldn't just hand tools to infantry soldiers and expect functional buildings. The work required knowledge, precision, and experience. In Germany itself, this system functioned adequately. Factories produced materials, trains delivered supplies, skilled workers completed buildings. But the moment Wehrmacht operations extended beyond German borders, cracks appeared in the system. In occupied Poland during 1940, German engineers discovered that local timber supplies were already strained. In France, they could requisition materials from the construction industry, but shipping those materials east to support Operation Barbarossa became a logistics nightmare. By the winter of 1941, when the Wehrmacht sat frozen outside Moscow, the traditional approach to barracks construction revealed its fatal flaw. It couldn't keep pace with operational needs. Soldiers on the Eastern Front desperately needed winterized shelter. The construction corps couldn't build fast enough. The mathematics were brutal. If one building took 6 weeks and housed 80 men, you needed 125 buildings to house 10,000 troops. That's 750 weeks of construction time. If you built them sequentially 14 years, even with multiple crews working simultaneously, you'd need dozens of skilled construction teams, mountains of materials, and months of good weather. The German solution involved requisitioning existing buildings in occupied territories whenever possible. In Polish towns and Russian villages, they simply evicted civilians and moved soldiers into houses, schools, and civic buildings. This worked temporarily, but created enormous resentment among occupied populations and couldn't solve the problem in forward areas where no buildings existed. When Rommel's forces pushed into Libya and Egypt, they faced environments with almost no local construction materials. Timber non-existent in the desert. Concrete possible, but cement and aggregate had to be shipped from Europe. Skilled labor. German construction workers were in short supply back home, let alone in North Africa. The Africa Corps increasingly relied on tents, captured British facilities, and improvised shelters that barely functioned in the desert heat. The engineered approach made sense in peacetime or in limited conflicts on Germany's borders. It failed spectacularly when applied to global warfare across multiple climate zones with overstretched supply lines. German quartermasters watched helplessly as construction timelines stretched. Material costs soared, and soldiers lived in inadequate shelter while waiting for proper barracks that might never arrive. While German engineers refined timber joints and poured concrete foundations, the U.S. Navy's Bureau of Yards and Docks faced an urgent problem. In the spring of 1941, Congress had just authorized a two-ocean navy, which meant constructing dozens of new bases practically overnight. The Navy needed thousands of buildings, needed them everywhere, and needed them yesterday. Traditional construction wasn't an option. They couldn't find enough contractors, couldn't source enough materials, and certainly couldn't wait 6 weeks per building. The Navy's construction division started looking at alternatives, and someone remembered the British Nissan Hut. Major Peter Nissen of the Royal Engineers had invented it during World War I, a semi-circular corrugated steel shelter that British forces used extensively in France. Simple concept. Bend corrugated iron sheets into a half-cylinder shape, bolt them to a steel frame close off the ends with wood, and you had shelter. The British built tens of thousands of them between 1916 and 1918. The Nissen Hut worked, but it had serious limitations. It was cold. Just single-layer corrugated metal with no insulation. It was dark. Minimal windows meant you needed artificial light even during daytime. It was cramped. The curved walls meant you lost usable space near the edges, and it required skilled labor to assemble. Those corrugated sheets needed precise alignment and specialized fasteners. The British used them out of desperation during World War I, but nobody considered them ideal. In March 1941, the Navy contracted with the George A. Fuller Company, a major construction firm based in New York, to redesign the Nissen concept into something that actually worked for modern military needs. The Navy gave them a testing facility at Quonset Point Naval Air Station in Rhode Island and issued a challenging brief. Design a building that's completely prefabricated, can be assembled by unskilled labor with basic tools, works in any climate from Alaska to Panama, costs under $1,000, and can be manufactured by the thousands per month. Otto Brandenberger, an engineer with the Fuller Company, led the redesign team. They started with the Nissen's basic curved shape but changed nearly everything else. First, they switched from corrugated iron to flat steel panels with a layer of insulation, sandwiched between inner and outer skins. This solved the temperature problem. The insulated panels kept interiors warm in winter and cool in summer. The panels were only 4 in thick, but provided better insulation than the German barracks double-wall construction. Second, they redesigned the structural system. Instead of a complex frame requiring skilled assembly, Brandenberger's team created a system of interlocking steel arches that fit together like a child's construction toy. Each arch section had pre-drilled holes that aligned perfectly with the next section. You didn't need to measure anything or cut anything on site. Just line up the holes, insert the bolts, tighten them down. A crew that had never seen a Quonset hut before could assemble one by following simple pictorial instructions. No written language required. Third, they added proper windows and ventilation. The end walls came prefabricated with window openings and door frames already installed. Ventilation louvers built into the structure prevented the interior from becoming an oven in tropical climates or a condensation-dripping nightmare. In cold weather, the breakthrough came in July 1941 when the first prototype went up at Quonset Point in just 16 hours with a 6-man crew. The Navy officers observing the test couldn't believe it. They'd watched German-style barracks construction that took weeks. This thing appeared in less than one workday. Better yet, when they disassembled it, loaded it on trucks, moved it half a mile away, and reassembled it. The same crew did it in 14 hours. The building was genuinely portable. The Navy approved the Quonset design in September 1941 and immediately placed orders for 5,000 units. Then Pearl Harbor happened in December, and those orders multiplied. By January 1942, the War Department wanted not 5,000 Quonsets, but 50,000. By summer, they wanted 100,000. The question became, could American industry actually manufacture these things fast enough? This is where American mass production culture revealed its enormous advantage. The Germans built things one at a time with skilled craftsmen. Americans built things on assembly lines with interchangeable parts. The entire U.S. economy had spent the previous 40 years perfecting mass production techniques, from Ford's Model T to Sears Roebuck's mail-order or House's top prefabricated diners. The Quonset Hut fit perfectly into this existing industrial ecosystem. The military awarded contracts to 36 manufacturers across the country. These weren't specialized defense contractors. They were companies that normally made grain silos, water towers, culverts, and industrial tanks. Firms like the Strand Steel Corporation in Indiana, the Great Lakes Steel Corporation in Michigan, the Balin Manufacturing Company in Nebraska. They already had the equipment needed: massive sheet metal presses, industrial bending machines, punch presses for drilling holes, and welding stations. Converting their production lines to Quonset manufacturing took weeks, not years. The manufacturing process itself was brilliantly simple. Steel sheets arrived from mills already cut to size. Presses stamped out the arch sections, each piece identical to every other piece of the same type. No custom fitting, no individual measurements, no craftsman decisions. The panel's four walls came pre-insulated from suppliers who sandwiched fiber insulation between inner and outer steel skins. Windows and doors were pre-hung in wooden frames at separate facilities. Everything arrived at the assembly point, ready to bolt together. At peak production in 1944, American factories produced 170 Quonset Huts every single day. That's one hut every 1 to 2 minutes during an 8-hour shift. The entire output of one day, 170 huts, could house roughly 5,000 soldiers. In the time it took a German construction crew to complete one traditional barracks housing 80 men, American factories produced enough Quonsets to house 21,000 troops. The cost advantages compounded with scale. The first Quonset prototypes cost around $1,200 each. By 1943, with mass production fully ramped up, the per unit cost dropped to $750. Some of the smaller models, the 20TX4T variant, cost as little as $600. Meanwhile, German barracks costs climbed as material shortages worsened. By 1943, timber scarcity in Germany meant the Wehrmacht paid premium prices for construction lumber, while simultaneously German barracks became less well-built due to substituting inferior materials. The standardization meant spare parts were truly interchangeable. A damaged panel from Quonset built in Indiana could be replaced with a panel manufactured in Nebraska 6 months later. They fit perfectly because the manufacturing tolerances were identical. The Germans had standards too, but their reliance on skilled labor meant each barracks was subtly unique. A window frame built by one carpenter didn't quite match the dimensions of a frame built by another. Doors required shimming and adjustment. Nothing was truly interchangeable. American factories also produced specialized variants at the same rapid pace. Need a Quonset with extra ventilation for tropical climates? Different end wall panels, same basic structure rolled off the line in Michigan. Need one with heavy insulation for Arctic conditions. Thicker panels, same assembly process, manufactured in Illinois. Need a 40FTX 100FT warehouse version? Just add more arch sections, bolt them together, done. The system was infinitely flexible while remaining completely standardized. The real test came on the beaches. In January 1944, Allied planners began staging Operation Overlord, the invasion of Normandy. Southern England transformed into one massive military base housing over 1.5 million American, British, and Canadian troops waiting for D-Day. Traditional construction couldn't possibly build enough facilities fast enough. Between January and June, U.S. Army engineers erected over 23,000 Quonset Huts across England. They served as barracks, vehicle maintenance depots, ammunition storage, field hospitals, mess halls, and command centers. When the invasion began on June 6th, the Quonsets came right behind the assault troops. Within 72 hours of securing Utah Beach, Army engineers had assembled prefabricated field hospitals on French soil. These weren't tents. They were fully enclosed Quonset structures with operating rooms, recovery wards, and supply storage. A soldier wounded on June 9th could be receiving surgery inside a proper building while the fighting still raged 10 miles inland. The speed advantage was literally saving lives measured in hours. The advance across France demonstrated the system's mobility. As Patton's Third Army raced east in August 1944, supply depots moved with them. Traditional warehouses impossible. But trucks carrying disassembled Quets followed directly behind the front lines. When the Army stopped, the buildings went up. A supply depot erected on Tuesday could be distributing ammunition by Thursday and disassembled the following Monday when the advance resumed. The buildings moved with the war. The Pacific Theater showed the Quonset's value even more dramatically. On Iwo Jima, Marines landed on February 19, 1945, beginning one of the bloodiest battles in Marine Corps history. By February 22, day 4 of the battle, while Japanese defenders still controlled most of the island, CBS had erected the first Quonset hospital near the beach. Wounded Marines were being treated in a proper building while the island was still a combat zone. At Okinawa in April 1945, the invasion plan specifically included Quonsets in the initial assault wave supplies. Within 1 week of the landing, despite heavy Japanese resistance, the island had 2 complete field hospitals, 3 major supply depots, and a repair facility, all Quonset structures. Speed of construction meant speed of operations meant faster victory. Compare this to German operations in the Soviet Union. When the Wehrmacht captured Sevastopol in July 1942 after an 8-month siege, they found the city destroyed. They needed facilities for occupation forces, supply storage, vehicle repair, and hospital care. Traditional construction began, but 6 months later in January 1943, most German troops were still living in temporary shelters and commandeered ruins. The infrastructure simply couldn't be built fast enough using conventional methods. When the Soviets counterattacked and retook the city in May 1944, much of the German construction effort remained incomplete. In the Aleutian Islands, American forces faced arguably the harshest environment of the war. When troops landed on Attu in May 1943, temperatures hovered around 35 degrees with constant fog and rain. Engineers erected Quonsets within days, providing weatherproof shelter in conditions where exposure killed as surely as bullets. The heavily insulated models designed for Arctic conditions kept men warm and equipment dry. Traditional barracks construction in those conditions would have been nearly impossible. You can't pour concrete foundations in permafrost, and timber frame construction fails in constant moisture. Guadalcanal provided perhaps the most telling comparison. Early in the campaign, troops lived in tents and suffered constant equipment degradation from humidity and rain. Quonsets arrived in December 1942. Functionality transformed overnight. Ammunition stayed dry. Radio equipment stopped corroding. Men slept in dry quarters for the first time in months. Medical supplies remained sterile. The difference between adequate and inadequate shelter meant the difference between an effective fighting force and one steadily degrading from environmental factors. The 15-to-1 cost advantage wasn't just about saving money. It was about what that money could buy instead. Every German barracks at $15,000 represented a resource allocation decision. That same $15,000 could manufacture 3 Sherman tanks at $5,000 each, or it could build 15 Quonset Huts housing the same number of men as those 3 German barracks with $12,000 left over for other equipment. Scale those numbers across the entire war. Germany built approximately 40,000 traditional military barracks between 1939 and 1945. At $15,000 each, that's $600 million in construction costs. The United States built 160,000 Quonsets at an average of $800 each, $128 million total. America housed 4 times as many troops for $155 the cost. The difference, $472 million, bought a lot of bombers. But the real advantage wasn't even the money. It was time. Time is the resource you can never manufacture more of, never import, never stockpile. Those 6 weeks to build a German barracks versus 16 hours for a Quonset meant American forces could respond to changing situations at speeds the Wehrmacht couldn't match. Consider logistics in mathematical terms. A traditional barracks required 15 to 20 skilled workers for 6 weeks. That's between 450 and 600 man-days of skilled labor per building. A Quonset needed 6 workers for 1 day, 6 man-day days of unskilled labor. The labor efficiency was 75 to 100 times better. And unlike the Germans, Americans didn't need to pull trained carpenters and electricians away from other critical work. Any infantry squad with a sergeant who could read instructions could assemble a Quonset. The transportation mathematics were equally favorable. One standard German barracks required approximately 12,000 board feet of lumber weighing roughly $30,000 lb. Add concrete, roofing materials, windows, doors, and hardware, and you needed multiple cargo trucks just to deliver materials for one building. A complete Quonset weighed $7,000 lbs, including all components. One truck hauled one complete building. The shipping efficiency was roughly 4 to 1 in terms of weight, even better in terms of volume because the nested arch sections packed efficiently. This efficiency compounded across the war. The U.S. Army calculated that shipping quets instead of traditional building materials to the Pacific Theater saved approximately 3 million tons of cargo ship capacity between 1942 and 1945. 3 million tons represented roughly 150 Liberty ship voyages. Each Liberty ship voyage from California to the Philippines took roughly 40 days round trip. The Quonsets freed up 6,000 ship days of transportation capacity that moved ammunition, food, fuel, and vehicles instead. The German logistics system, by contrast, consumed itself. As the war progressed and material shortages intensified, Wehrmacht Construction Corps had to source timber from increasingly distant locations. Lumber came from Norway, occupied Poland, Romania, anywhere forests still stood. The transportation costs spiraled. A German barracks built in 1944 consumed more resources and took longer to complete than one built in 1940, because the supply chain had deteriorated so badly. American production, meanwhile, accelerated. The 1944 Quonsets were better than the 1941 models. Improved insulation, better ventilation, stronger panels, but they cost less and assembled faster because manufacturing processes kept improving. Ford Motor Company applied assembly line lessons learned from automotive production. What took 16 hours in 1941 took 12 hours by 1944 with an equally inexperienced crew. The strategic impact showed up in operational tempo. American forces could establish new bases, expand existing facilities, and relocate entire installations at speeds that bewildered German intelligence. When the U.S. built airfields in China to support B-29 operations against Japan, those bases went from empty fields to operational facilities with housing, maintenance shops, and supply depots in weeks. The Japanese expected months of construction time, the standard timeline for building with traditional methods. They kept bombing construction sites that were already finished and occupied. By 1945, the accumulated advantage had become overwhelming. The United States had infrastructure everywhere, while Germany's construction capacity had collapsed along with its ability to source materials. When the war ended in August 1945, the American military found itself owning 160,000 Quonset huts scattered across 46 countries and every U.S. state. The question became, what do you do with all these buildings? The answer reshaped post-war communities across the globe. The Surplus Property Act of 1944 allowed civilians to purchase military equipment at pennies on the dollar. A Quonset that cost the government $800 sold for as little as $100 to veterans, farmers, businesses, and churches. Suddenly, instant buildings became available to anyone. On college campuses, universities bought hundreds of surplus Quonsets to house the flood of veterans attending school under the GI Bill. The University of Wisconsin erected an entire temporary campus of Quonsets in 1946 that housed classrooms and dormitories for 2,000 students. Those temporary buildings remained in use until 1968. Farmers discovered Quonsets made perfect machine sheds, grain storage, and livestock barns. The curved roof shed snow naturally. The steel construction resisted rot and pests, and the open interior required no support posts. You could drive tractors and combines straight through. By 1950, an estimated 40,000 Quonsets served agricultural purposes across rural America. Many still stand today, 75 years later, still functioning as intended. Small business owners turned them into diners, auto repair shops, warehouses, and manufacturing facilities. In post-war suburbs, entire commercial districts consisted of repurposed Quonsets. They weren't pretty, but they were functional and affordable. A veteran with a welding business could buy a Quonset, bolt it together on a weekend, and open for business Monday morning. Traditional commercial construction would have required months, and bank loans most veterans couldn't qualify for. Churches, desperate for meeting space in rapidly growing suburbs, bought Quonsets by the thousands. A congregation could purchase a building, assemble it with volunteer labor, add a cross to the end wall, and hold services the following Sunday. Hundreds of these Quonset churches operated across America through the 1950s and 60s. Some denominations used them as permanent structures, others as temporary facilities until they could afford traditional buildings. The architectural profession initially dismissed Quonsets as wartime expediency, ugly, utilitarian, beneath serious consideration. But some younger architects recognized something important in that curved steel form. The Quonset proved you could create functional shelter without traditional materials, skilled craftsmen, or months of construction time. It demonstrated that prefabrication worked, that standardization enabled affordability, and that speed didn't necessarily mean inferior quality. These lessons influenced the post-war prefab housing movement. Buckminster Fuller's Demaxian House, the Lustran all-steel homes, and later developments in modular construction all owed intellectual debts to the Quonset concept. The idea that you could manufacture buildings in factories and assemble them on site became mainstream instead of radical. Internationally, Quonsets spread everywhere American forces had served. In England, thousands remained and served as everything from village halls to cricket clubs. In the Philippines, Quonsets became schools, clinics, and community centers. In Iceland, they housed NATO operations for decades. Australia used surplus Quonsets for rural infrastructure well into the 1970s. The German barracks, by contrast, mostly disappeared. Those that survived the war were either destroyed during Allied bombing, dismantled for materials during post-war reconstruction, or simply abandoned and left to decay. A few remain today as historical sites or military museums, monuments to an engineering philosophy that couldn't adapt to industrial warfare's demands. The Quonset's legacy lives on in modern military operations. Today's deployable shelters use advanced materials, aluminum instead of steel, synthetic insulation instead of fiberglass, computerized climate control. But the fundamental concept remains unchanged. Prefabricated sections, rapid assembly, complete portability. The current military shelter system can be traced directly back to that 1941 breakthrough at Quonset Point. Sometimes the best solution isn't the most elegant or the most engineered. Sometimes it's just the one that works fast enough, cheap enough, and reliably enough to win.